Okay, so when we evaluate these functions, they're telling us what x value to go to. And in the case of number 11, I'm going to mark on my drawing in orange, it's f of negative 4. If I go to where negative 4 is on the x-axis, I'm putting in negative 4 for x. I'm going to come up and find out that the y value there is 2. I go to where it is on the line. I'm going to move ahead to number 12. 12 is asking for what's the y value when x is 0. And it's right there on the origin. 0. When x is 0, y is 0. That's in my blue point that I have there. I'm going to look at number 13. Evaluate this function when x is 2. When x is 2, I come here and see that it's got a y value of negative 2. And when I move along to evaluating when x is negative 5, grab a different color, use my purple here. At negative 5, the y value is also 0, just like it was here. Now I'm going to move ahead with writing the inequalities for number 15 and 16. In number 15, Felsman writes, I recommend the ambient humidity for a cage be at least 60%. If H represents the ambient humidity for a cage in percent, write an inequality to represent it. His humidity has to be at least. So it's got to be greater than or equal to 60%. In number 16, he talks about writes about getting the snake set up in a secure cage will probably cost more than the snake itself. If a ball python costs $80 to purchase, and C represents the cost in dollars. Oops, this is a dollar sign. We just were told that the setup is going to cost more than that. The setup costs more than the snake itself, and they told us that the snake is 80. Moving on to number 17. Decide whether or not the table represents linear or exponential relationship. In a linear relationship, what we really were learning about is that you have something that's a constant that's added or subtracted. And if it's not linear, we can look at the possibility that it could be exponential, where you have something multiplied or divided. Now, in the case of number 17, when I look at 17, it looks to me like it's getting bigger pretty fast. And the way that you can go and check this is to work backwards. If I take 240 minus 60, I think that's going to be 180. If you got a calculator open, you can check. So is this going on that I'm adding 180? What do you think here? 240 plus 180? Is that 960 or is that too big? I think it's too big, isn't it? So I'm going to go and say this isn't going to be linear because it's not added. What do you notice, Jalen? I think all the way through. Multiply by 4. Multiply by 4. Check a couple of those. Go from one to the next. Is it times by 4? If that's the case, that's going to be an exponential relationship. I think we got the same kind of thing going on in number 18, in that in number 18, boy, if I went and tried to add, I see that difference it's a lot bigger gap between the numbers. And if there's a big gap between the numbers like that, oftentimes it is exponential. And I can look at the relationship between 12 and 36, and I know that that is 3 times bigger. And if I take 36 times 3, check me in your calculator, 3 times bigger. And this one's times 3 all the way down. Puts that one as an exponential as well. I see a different kind of change in number 19. I see that linear change in 19. And in the case here, I'm showing that subtracting 1. Now the directions for this did say show or explain how you know. I like my show how I know. You could talk about it in a complete sentence, but this would be adequate if you had it just shown in the changes in the table. Now what I'm going to do for number 20 through 21 is I'm going to use the information in the table. about the, actually I'm going to start this one in another video, sorry.